2212. This is my Lab 2 Charge Tape Revisited. Introduction. The purpose of this lab will be to determine the charge between two charged Scotch tapes. This experiment will be conducted by resting one piece across two parallel shelves and holding the other piece below it. While this lab is very similar to Lab 1, the computational model changes. Instead of a single point charge, we will be modeling a line of multiple charges. Assumptions. Each piece of tape had an equally distributed charge in order to apply Coulomb's law. Air resistance is negligible. We treated the long tape as though it were multiple charges in a line. Each U-tape has the same net charge, and all tape is 1 atom thick. The results are as such. Charge on both tapes, 1.481 times 10 to the negative 8 coulombs. So fundamental principles. Of course, we have the formula for gravitational force, which is mass times gravity, or the gravitational constant. And we have the electric force, which is Q times electric field, electric field, or Q squared times K divided by D squared. The procedure is as such. One at a time, place tape A and B, or the U-tape on top of the base tape and pull off quickly to charge the tapes. Hover tape A under tape B, making it float. Record the displacement. Experiment setup. The system is tape B and tape A. Surroundings are gravity and everything else in the room. Initial conditions. Tape dimensions were 0.02 meters by 0.2 meters. Tape mass was 0.0002 kilograms. Gravity, of course, is 9.81. Displacement was 0.01 meters. Observations. The U-tape was attracted to my hand, repelled from another piece of U-tape, and was attracted to a neutral book, which means it is positively charged. Oh, and was attracted to a negatively charged pen. Determining the force of gravity. Of course, we know that the force of gravity is mass times the gravitational constant. The mass was found to be 0.0002 kilograms, and so times that by 9.8, and that will give us the gravitational force. And because there is no acceleration in this equation, or we're assuming that, then the electric force equals the gravitational force, which is how we derived the number of coulombs, or charge. Computational model time. So here's our glow script code. As you can see here, here's our line of charges and all our forces that are combining to be this force right here. And this is the magnitude of the gravitational force, as we predicted earlier, and this is our predicted force of electricity. Here's the mass, the coulombs that we put in as a prediction after we did the formula. Then this is our tape length, this is the distance or the displacement. Then, of course, we have all our formulas that we plugged in and we showed prior to create all our things. Here's the creation of our vectors and the rest of our formulas and inputs as such here, which resulted in this output. Very nice. Okay, sources of error. In the experiment, unequal charges on each tape was most likely present because there's no way we could perfectly charge each one using two pieces of tape. I'm sorry, but it's just not possible. The charge was not equally distributed. It's most likely to say that was the case, as we were not able to truly determine how much or where we charged that tape to be exact. Some charge was most likely lost on the tape during handling. Unfortunately, when we were handling the tape and touching it, most likely charge was lost. Also, we were eyeballing the displacement, which means it can easily be off and not very accurate during the modeling phase. While it was much more accurate than Lab 1, however, it's still not perfect, as we broke the tape into a finite number of pieces, whereas in reality, it's a straight line. What if? What if we had modeled each of the tapes, as a single point charge? Well, that's what we did in Lab 1. The Lab 1, we got the charge of 4.669 times 10 to the negative 9 coulombs, which, as you can see when you look at Lab 2, which is 1.481 times 10 to the negative 8 coulombs, which is still slightly off. As you can see here, the difference between the two was decent. Then we can assume that as you increase the number of points or the line of charges, it becomes more accurate, which leads us to our next question. Why do these estimates differ? The second lab is more accurate, as it accounts for a more accurate number of charges present, as we can assume that this piece of tape is more than just a single point, but a line of charges. In fact, in some ways, an infinite line. So, thank you so much, guys, for listening, and I hope you enjoyed this lab and learned something new. Adios.